In this video, we're going to look at polynomial inequalities. And this section is really similar to quadratic inequalities that we did earlier, except for it's going to require a little bit more factoring and then checking more regions or more intervals. So in the first example, we have x cubed is less than or equal to 16x. So the first thing I'm going to do is move everything to one side. So I have x cubed minus 16x is less than or equal to 0. And now I'm going to factor an x out of the left side. So I have x times x squared minus 16 is less than or equal to 0. And now x squared minus 16 is a perfect square. So we have x times x plus 4 times x minus 4 is less than or equal to 0. So now we found all our zeros. We have it at 0, -4, and 4. So we set up our diagram, and we have -4, 0, and 4. And now I'm going to test a number in each interval. So from -infinity to -4, I'm going to use -5. So -5 is a negative number. So what I like to do when I have more than just 2 like we did in the quadratic is actually write the signs out inside the interval. So we have a negative value. -5 plus 4 is a negative value. And -5 minus 4 is a negative value. So we have 3 negatives, which equals a negative. In the second interval, I'm going to use -1. So -1 itself is negative. -1 plus 4 is positive, and -1 minus 4 is negative. 2 negatives and a positive gives us a positive. Now I'm going to use 1. So I have 1 itself is positive, 1 plus 4 is positive, and 1 minus 4 is negative. So we have 2 positives and a negative, so we're negative. And then in the last interval, I'm going to choose 5. 5 itself is positive, 5 plus 4 is positive, and 5 minus 4 is positive. So 3 positives gives us a positive. So now we are looking for when we are less than or equal to 0. And that's between -infinity and -4, including -4 because of the or equal to. And then between 0 and 4, including both of them. So in interval notation, we would have -infinity to -4 union 0 to 4, including all of our endpoints except for -infinity. In the next example, we have x to the 4th plus 4 is greater than 5x squared. So the first thing I'm going to do is rewrite it as x to the 4th minus 5x squared plus 4 is greater than 0. And now I'm going to factor this, and I'm going to write this as x squared minus 4 times x squared minus 1 is greater than 0. Now, for some people, it will be easier to rewrite this. So with one substitution, I can rewrite this to make this look a lot more like a quadratic. And I just wrote it in stride as a quadratic. So what I really did is I said that x squared is equal to u. If I rewrite this with the substitution, I'll have u squared minus 5u plus 4 is greater than 0. And now it's a little easier to see that this is u minus 4 and u minus 1 is greater than 0. And then if we resubstitute and we have u is equal to x squared, we get x squared minus 4 and x squared minus 1. And now each of these factors are also perfect squares. So we can write this as x plus 2 and x minus 2 and x plus 1 times x minus 1 is greater than 0. So we're going to have a lot of intervals here because we have zeros at plus and minus 1 and plus and minus 2. So we have, I'm going to draw this big. So we have -2, -1, and 1, and 2. So now, if I choose -3, I have negative, and -3 minus 2 is another negative, and negative again, and another negative. So 4 negatives. 4 negatives makes a positive. And now if I choose -1.5, we're going to have -1.5 plus 2 is positive, and then negative in the second factor. And -1.5 plus 1 is negative, and then negative again. So we have 3 negatives and a positive, giving us negative. And for the next interval, I'm going to use 0. So I have positive, positive, and negative. So we have 2 negatives, 2 positives. We're positive. And between 1 and 2, we have 1.5. So the first factor is positive. Second factor is negative. Third factor is positive. And the last factor is positive. So 1 negative, 3 positives gives us a negative. And then if I choose 3, every factor will be positive. So I have all positives or positive. And now we were looking for when x to the fourth minus 5x squared plus 4 is greater than 0. So we're not going to include any of our zeros. And we were looking for when it's greater. So everywhere where we have a positive mark, from -infinity to -2, -1 to 1, and from 2 to infinity. So we have -infinity to -2, union, -1 to 1, union, 2 to infinity. And that's the solution to this inequality. And that's all for polynomial inequalities.